I'm Dave Cummins from Future Property Group, and welcome to the Future of Sustainable Development, a podcast where we explore the ideas shaping tomorrow's built environment. Today, we're exploring the importance of heating and cooling loads on buildings. What is it? Why it's important? And how do we embrace it? When we talk about heating and cooling loads, we're really talking about how much energy a building needs to keep its occupants comfortable. It's about how much heating is required in winter and how much cooling is required in summer. Sounds simple, but it's actually one of the biggest drivers of energy demand worldwide. According to the International Energy Agency, heating and cooling accounts for about 50% of global building energy use. And when you remember that the property sector as a whole is responsible for 39% of global carbon emissions, this one factor, keeping people comfortable indoors, becomes a front-line issue for climate crisis. The history of this challenge is fascinating. For thousands of years before mechanical systems, humans relied on passive strategies to control indoor climate. Ancient Persians built wind catchers to funnel breezes into homes, while Romans used hypocrust systems to channel warm air under floors. In Japan, light, wooden houses with deep eaves encouraged airflow and shaded interiors. But the Industrial Revolution changed everything. With the invention of mechanical heating and cooling, we stopped designing with climate in mind. We started sealing up buildings and relying on machines to do the work. As a result, cooling alone now accounts for over 10% in global electricity use, according to Nature Energy Journal. The consequences are staggering. A study in Applied Energy Journal estimated that inefficient heating and cooling contributes to about 2.5 gigatons of CO2 emissions every year, roughly the same as the entire annual emissions of India. In Australia, the Department of Industry, Science and Research has reported that heating and cooling accounts for 40% of household energy use. That means nearly half of what we spend on power bills is simply to keep our homes warm or cool enough to live in. So what's the benefit of tackling heating and cooling load properly? First, it saves money. Research in Energy and Buildings Journal show that integrating passive design measures like insulation, shading, and natural ventilation can reduce cooling demand by up to 50%. In Singapore, studies have shown that green roofs and facades lower ambient air temperatures by 2 to 4 degrees Celsius, cutting peak cooling demands by a quarter. Second, it saves lives. Environmental health perspectives published research showing that heat waves increase mortality by 40% in poorly designed housing, with climate change driving more extreme weather. This is not just about being comfortable, it's about survival. Third, it boosts productivity and well-being. Harvard's T.H. Chan School of Public Health found that poor indoor air quality and inadequate thermal buildings reduced cognitive function by 20%, while well-ventilated, temperature-stable environments increased performance by more than 60%. When we get heating and cooling right, we don't just save energy, we unlock human potential. So why do we not embrace this more? Part of the problem is cost perception. Developers often see insulation, shading devices, and advanced glazing as extras rather than essentials, even though research in building and environments show that these actual measures pay back within 5 years through energy savings. There's also cultural inertia. For decades, success in property was measured by square meters delivered, not by kilowatts saved. And then there's a split incentive problem. Landlords build cheaply and tenants pay through energy bills. There is little motivation to invest in efficiency. Another barrier is technology bias. We've come to rely on mechanical systems as the default, rather than designing buildings to work with, not against the climate. Yet research in renewable energy shows that integrating passive strategies with renewable energy can reduce total buildings' energy use by more than 70%. The science is clear, but the industry is still catching up. But there are shining examples. In Australia, the Council House 2 building in Melbourne was designed with passive cooling, natural ventilation, and thermal mass, reducing its energy use by 50% compared to a conventional office. In Barangaroo in Sydney, buildings integrate shading, seawater cooling, and high-performance facades, achieving carbon-neutral operations. Globally, Singapore's Marina One integrates sky gardens and cross-ventilation strategies that help cut cooling demand and dramatically in tropical climate. In Europe, the Passive House movement has delivered more than 60,000 ultra-efficient homes with heating and cooling loads so low they use 90% less energy than standard buildings, as documented in Energy Policy Journal. So how can we embrace more of this? First, go back to basics. Orientation, shading, insulation, and ventilation are low-tech, cost-efficient solutions with massive impact. Second, measured performance. Post-occupancy studies published in Building Research and Information revealed that many buildings underperform because actual energy use isn't tracked. Making measurement mandatory would close the gap between design intent and lived reality. Third, aligned finance. Green loans and sustainably linked bonds can reward developers who deliver buildings with proven low heating and cooling loads. Finally, education. Architects and engineers need to see passive and climate response design not as an option, but as core professional responsibility. What needs to change? We need regulation that values lifecycle performance over upfront costs. We need to shift cultural narratives so that a modern building means one that works with nature, not against it. And we need leadership. Developers and governments willing to say that buildings designed for high energy demands are simply no longer acceptable in a climate-constrained world. What would happen if we got this right? Cities would see lower energy bills, cleaner air, and more resilient communities. Families would be safer in heat waves and more comfortable year-round. Workers would think more clearly and perform better. Developers would see stronger asset values and lower vacancy rates. And critically, we would take a massive bite out of the property sector's carbon footprint. A study in the Lancet Planetary Health journal concluded that widespread adoption of energy-efficient heating and cooling loads could cut global emissions by up to 15%, enough to keep us within reach of the Paris Agreement climate targets. The take-home message is this: heating and cooling loads aren't just technical details, but are a defining factor in our fight against climate change, our ability to thrive in cities, and economic resilience. We already have the science, we already have the design tools, we already have the examples. What we need now is the courage to make them the norm. Because when we design buildings that keep us comfortable without cooking the planet, we prove that progress isn't measured in air conditioners sold or kilowatts burned. It's measured in healthier people, lower emissions, and communities built to last. Thanks for tuning in to the future of sustainable development. Join us next time as we uncover fresh research, new innovations, and best practices for building smarter, greener, and more resilient buildings. Until then, let's continue to build places that heal the land and empower communities for tomorrow.